Hi, I'm EyeOnAiman, and welcome back to another one of my FischerTechnik videos. In today's video, we're going to be solving another FischerTechnik challenge, and today it's going to be Eager Eddie's Earthquake Machine Challenge. So this is a bit of a cooler challenge. Let me just press start here. So first off, right off the bat, we're simulating the motion of an earthquake. This is a bit of a cooler challenge and a bit more of an intense challenge in all three areas, mechanical, computer, and electrical, because you're going to be using a lot more critical thinking in all three. As a mechanical engineer, you're going to be figuring out how to use the rack and pinion mechanism, which is this pinion providing rotational motion, and then this rack translating that rotational motion into linear motion. And you're going to be figuring out how to build this mechanism, also while keeping it stable and in place, just to simulate how that earthquake works. Next up, as the electrical engineer, you're going to be working with some cool sensors, and also figuring out how they're wired a bit more. And finally, as a computer engineer, you're going to be figuring out how to program this loop. And so we're going to start that program right back up again. So you can see that when this rack pushes this button, it starts going backwards. And when this rack blocks the light from the sensor, it also reverses the direction of the motor. So you're going to be using these two sensors. You're going to be using a push button and a phototransistor to simulate that earthquake. And so this is a very cool challenge because first off, you just get to use the push button without actually pushing it yourself, unlike the last challenge. Now the rack is what's pushing it, so you want to make sure that rack actually touches it. And then you're also going to be using one of my favorite FischerTechnik parts, which is this transistor right here. And so this phototransistor is like the photoresistor. It detects light levels. But unlike the photoresistor, it's only 1 or 0. It doesn't have a range of values that it detects, a range of light values that it detects. It only detects if there's light or there's no light. And so if we look at I4 here, this is when there is no light being detected. But if I put it in front of this light bulb right here, you can see that it detects an input. And so you can see that the phototransistor toggles on and off when it's not in front of the light. And so in order to wire this phototransistor, you might have to wire it in a pretty weird way. I had to wire it like this. So you guys will have to figure out how this phototransistor works. You're going to also have to figure out how to work it with your programming, because these wait for input buttons might require some specific finagling in order to work with the phototransistors. And lastly, for the computer engineers, you're going to have to figure out how to make this loop work without human interaction. You're going to have to figure out how it detects each input, each sensor, so both the light sensors and the push button sensors. And then you're going to have to figure out how to make that all loop back together. And so if we start the program again. Alright, and so that's the challenge. Good luck on completing it, and I'll see you in the next one.